Welcome to Virtual Math Masters. I'm your boy, Master Cruz, so you never do math alone again. And today we're going to talk about compound inequality. So let's jump right into it. Just as a review basics, they have four different types of inequalities. We have less than or equal to, we have greater than, and we have greater than or equal to. And when we graph, the way that we show less than and greater than are with open circles, because that number is not included in our answer, also is not part of the solution. And then if we ever are going to graph less than or equal to, we're going to use a closed circle, because we learned that this line at the bottom, which is the equal to symbol, this line at the bottom fills in the circle inside. Okay, so this line fills in the circle inside. So let's just jump into example one. Remember that this no equal to not included, and with the equal to symbol at the bottom, yes included. So graph the compound inequality x is less than 1 and x is greater than -2. So now we have two inequalities on the same problem, which means that we're going to do this two times on the same number line. But final answer, we will have only one number line. So this is what it means. First, we're going to graph the first one. This is that x is less than 1. So I'm going to go to my number line, and I always create a number line with 0 as a reference point. And I know that positive 1 is on the right-hand side of 1. So I'm just going to label this right here 1. Okay, so I'm not going to draw a bunch of tick marks. I'm just going to draw the tick marks they give me. And because this is just less than, I'm going to have an open circle. Now, here we go. This is going to be an open circle and going to the left because it's less than. And that's where the numbers that are less than 1 are on the number line. They're to the left of less. So therefore, you go to the left. Also, if you look at this as the head of the arrow that is pointing to the left, this head of the arrow, it's also pointing to the left. You can always follow that as long as the x is first. And x is greater than or equal to -2. So we're going to go to the number line. We're going to label -2. -2 is somewhere to the left of 0 on the number line. And I'm going to graph this blue. Okay, so I'm color coding this so that we know which one we're looking at. Now I'm going to go to -2, and -2 is included because it has the equal to symbol at the bottom. So when I draw my circle, I'm actually going to close it. This is a closed circle. And where are the numbers that are greater than or equal to -2? To the left of -2 or to the right of -2? Well, they're to the right of -2. Now, because this says and this is why I highlighted this word, that word is very, very important. Because what that means is I want numbers that are only less than 1 and are greater than -2. Because I graphed it, those numbers are where they overlap. So all this region right here that overlaps, that's my solution. Therefore, my final answer, it's going to be a number line that is going to include 0. It's going to have the -2 and the +1, but it's not going to have the blue and the red arrow. It's only going to have one that it's going to, where do they start overlapping? If I'm reading this from left to right, remember everything that we do in math is from left to right, where do they start overlapping? Well, it starts overlapping at -2, and here is a closed circle because -2 is included. So I'm going to have a closed circle. I'm going to keep going. All these numbers are greater than -2 and less than 1 until we hit 1. And here, this is not included. So I'm going to have an open circle, and I'm just going to connect them. Okay, so every single number from -2, -1.999, -1, 0, 0.1, 0.2, all the way up to 1, all these numbers satisfy my inequality. So this is my answer. So notice that I had to do two number lines. The first number line was to see where they at, and the second number line was to define the correct answer. Okay, so that was with the word and. Now, when we talked about compound inequalities, you're going to get two important words. The first word is and it means that both of them have to be satisfied. The second word is or. Okay, now I already graphed this one for you because this is the same problem. This is x is less than 1 or x is greater than or equal to -2. The difference here is the following. The word and requires both of them to overlap. It's like if you go to Chick-fil-A and you want a chicken sandwich and the waffle fries, and you tell your parents, hey, can I get a chicken sandwich and the waffle fries? If they bring you just the fries, that'll be kind of messed up because you need a both, not just one. If they just bring you the chicken sandwich, man, you're missing on those waffle fries. All right. So you need to bring me both of them. I want the chicken and I want the fries. But if you go right, and I change the word, the requirement instead of and or takes everything. If I say just bring me one thing or the other, I don't think what you bring, I don't care what you bring or what you not bring, as long as you bring me something, we're good. So over here, I'm gonna take everything into consideration. If I were to graph these two here, hopefully you can see that x is greater than -2 goes that way, x is less than 1 goes that way, and this is included. So it covers the entire graph. So I'm not going to draw two lines. I never want two lines on the same graph. I'm just going to draw one that covers everything, because every single number is less than 1 and it's greater than -2. If it's an or, then this is all real numbers. So all real numbers satisfy this or, and that's it. That's example 2. It's the same problem, but hopefully you can see the difference between and or. For and, I'm looking for an overlapping. For or, I take everything. It doesn't matter if it overlaps or not. Let's go to example 3. And means no overlapping. So if I were to graph x is less than or equal to -5 in red, I will, I have the 0, I'll plot the -5, and I'm going to go to the left. This is included because the equal to symbol is at the bottom, and this line fills in the circle. So it's going to the left. And, well, you have x, it's greater than 2, and I'm going to do it blue, so I'm going to go to the 2, open circle, because there's no equal to, so it's open, and it's going to the right. Because it's an and, I'm looking for overlapping. But as you can see, there is no overlapping anywhere in this problem. Therefore, there's no solution because they never overlap. If they were to overlap, then you will have a solution like before, but right now we don't. And these are different ways that you could see it. You could see no solution, or you could also see the symbol, which means the empty set, which we saw at the beginning of the year in our vocab words. So the empty set. So that's how you do that. Now, what happens if I change this to or? Because I could change this to or, right? Well, if I change this to or, then that's it. This is the end. This is the graph, right? This graph right here, that's the graph, because or does not require overlapping. So this will be the correct graph. So notice that the same problem, if I change the word and or the word or, it will completely change my answer. All these numbers that are covered, -6, -7, -100 all the way there, or 3, 5, 10, 100 all the way here. Those are all solutions if I put the word or. If I put the word and, there's no overlapping, so there's no answer. All right, that's perfect. That's example 3. Let's go to example 4. Now, example 4 requires a little bit more of work. So here we go. I have to solve the first inequality independently, and I'm going to solve the other inequality independently. So just so that I don't forget, because I have the word and, I'm actually looking for whenever this overlaps. So that's my goal, right? I'm going to graph these on the same number line, and I'm going to look for places where they overlap. So let's solve the first one. This is a two-step inequality, not that bad. Okay, so I'm going to subtract 9 from both sides, because, I want x by itself, but x is not by itself because it's being multiplied by 5 and added by 9. So I subtract 9 from both sides using my inverse operations. And then I'm going to have 5x is less than or equal to, 9 minus 9 is 0. So 24 minus 9 is going to give me 15. And we're almost done. Why is x not by itself? Because it's being multiplied by 5. So the inverse operation on both sides will be divide by 5 on both sides. And if I do that, that's going to give me that x is less than or equal to 3. 15 divided by 5 is 3. So I already have my first part. So I know that one of my answers is going to be x is less than 3 and, okay, because this is an and problem, then I'm going to solve the right-hand side independently. So here we go. Again, I need to get x by itself, and x is not by itself in this side of the inequality symbol because it's being multiplied by -3 and subtracted by 7. So I'm going to add 7 to both sides. This cancels, and I'm going to have -3x is greater than, notice that I try to keep this aligned, 14 plus 7, that'll be 21. Okay, that'll be 21. And then if I do, if I want to get x by itself, I'm going to have to divide both sides by -3. So -3. Okay, this cancels. Then you're going to get the x. Now, very important, and hopefully you remember this rule, when you're dividing by a negative number, you have to flip the inequality side. So this is going to be less than, and then 21 divided by -3 is actually -7. Okay, that's -7. So I'm flipping the symbol, I'm flipping the symbol, I'm flipping the sign. Perfect. So I have this, and now I can graph it. So I challenge you, if you can, pause the video real quick and try to graph this before I graph it. Okay, if you're not sure, you can continue, but I'm going to give you a second here so you can pause. All right, hopefully you pause. If not, that's okay. If you pause and you did it, check if you got the right answer. That would be amazing. The first number that we got is 3. So I'm going to go here to +3. Okay, so I'm going to mark +3 somewhere around here. And I'm going to go with blue on this one. Is this number included? The correct answer is yes. Right here, this is included because it's equal to. So this is going to be a closed circle. Okay, this is going to be a closed circle, and it's going to the left because that's where the numbers are less than 3 are, to the left of 3. Then I'm going to go to x is less than -7. Well, -7 is somewhere here. Okay, -7 somewhere on this side, so -7. And I'm going to graph this red. So this is not included, okay, because there's no equal to. So this is going to be an open circle. And the numbers that are left to the left are less than -7. So we're also going to the left. Now, remember, this is an and problem. So we only care of where do they overlap. Well, these only overlap over here, actually, on the left-hand side. So my final graph, which is the answer graph, okay, goes to -7. And then there is right here a closed open circle. This is an open circle, and it's going to the left. This is my final answer. That is the and, because that is where they overlap. Okay, that's where both of answers overlaps. So that's example 4. We're almost done. I hope that you're getting the hang of this. So let's talk a little bit different of and in a little different way. Sometimes you get problems with a compound inequality like this. You have a number, you have the less than sign, you have something in the middle, okay? You have another less than sign, and then you have a number at the end. So you start here, less than x, less than, you end here. Less than sign is actually going to be your best friend now. So less than signs are good because you start on the left and you end on the right. So this is telling you where to start and where to end when I create my graph. However, before I do that, I got to make sure that x is by itself. So when I look at the middle and I see why it's x not by itself, it's because it's being added by 8. So the inverse operation of adding 8 will be to subtract 8. So I'm going to subtract 8 from both sides. So I'm going to put -8. But see, now I have 2 different symbols. So it's not just 2 sides. I'm going to subtract it from everything. I have to subtract it from before the less than sign, and I have to subtract it from the 10 as well. So -8, -8, -8, this cancels. And here we go. We get that 7 minus 8 is -1. So this is going to be -1. My less than sign, my less than symbol is here. 8 minus 8 goes to 0. That cancels. So it's just the x by itself. I have the less than sign here. And then 10 minus 8 is 2. As you can see, X is all alone by itself. So this is perfect. This is my final answer. Well, I'm not going to box it yet. What I want you to see right now, I'm not going to box it yet, is that this is the number where you start, and this is the number where you end. Okay, this is the number where you start, and this is the number where you end. So if I were to graph this, check it out. I'm going to have a number line. Okay, I'm going to have a zero. I'm going to have a zero here. I am going to have the -1. I am going to have the +2. And I'm going to do this very above, so I only draw one line. Check it out. I'm going to do the left one. I'm going to do it in blue. Okay, so I'm going to box this part. And sorry, before I do that, I'm just going to start at -1. Check it out. I'm going to start at -1 because this is what it's saying. And it's open circle because that's where you start. Okay, that's where you start. Oops, I don't know what I erased. There you go. That's where you start. So this number, you start -1, and where you're going to end? You're going to end at 2. So close circle at 2, and then you connect them. You start here and you end here. So you start at -1 and you end at +2. That's it. That is my answer. That is the answer. There's nothing else. Now, this is an and type of problem, and this is what I wanted to show you. And let me show you how. If I were to split this only on the left-hand side, so I'm going to take only the x and I'm going to stop right here, okay? If I were to graph this, the left-hand side, hopefully you can see that this is the same thing as me saying, well, if I put the x first, right? And this symbol is, if it was Pac-Man and it's eating something, it's going to eat the x. So it still has to be eating the x. And I have the -1. If I were to read this, this says that x is greater than or equal, this is greater than -1. So I'm going to have an open circle going to the right. X is greater than 1. Now, if I were to do the second part on the right-hand side, and that's what's pretty cool about this. So I'm going to do this in red. Okay, I'm going to do this in red. I can just bring it down here and say that x is less than 2, right? And if I were to graph this, I will go here and I'm going to go to the left. And we said that this is the same problem as an and. Okay, this is an and. So this is an and problem. If it was an and problem, I only care about where they overlap. So if I'm right here, they overlap this area and this area. Well, this area happens to be from -1 all the way to 2. So this is the great thing about knowing that if a problem is set up this way, you just start here and you end there. Like you start here and you end there, because you didn't have to do all this that I did here to know that, hey, you just put a -1 and you end at 2. So that's the magic of this. You start on the left, you end on the right. Let's do the last problem, because this is the most challenging problem when you have like different numbers. What do you do? Well, the goal here is to get x by itself inside. And the reason why x is not by itself inside, it's because it's being multiplied by -3 and added by 1 and divided by 4. These numbers that I highlighted, those are the numbers that we want to cancel. Now, out of all these numbers, what is the number that you want to cancel first? Well, the number that you want to cancel first is the 4, right? Because you have a fraction, you want to cancel the fraction by multiplying by the denominator. That's how we cancel fractions. So I'm going to multiply everywhere by 4 so I can cancel it. Okay, so let's cancel it. 4 times -32, sorry, times -8 is -32. So this is going to be -32 less than or equal to. Now, you don't actually have to multiply the 4, because when you multiply this 4 times that's 4, it cancels. And you just drop whatever was in the middle. So you drop the -3x plus 1, drop the less than or equal to sign, and then 2 times 4 is 8. So this is looking way better now because, hey, it's a two-step inequality. All you have to do is move, divide, move, divide. So if I subtract 1 everywhere now, I have to subtract 1 everywhere. -31 minus 1, it's going to be -33, which is less than or equal to -3x, which is less than or equal to, because the 1 minus 1 is 0, 7. So we're almost there. And our last step is to, hopefully you guessed it before I did, we need to cancel that -3. And the way that we do that is we divide by -3 everywhere. We divide by -3 everywhere. Okay. So because we're going to divide by -3, this cancels, and you get the negative divided by negative to positives, and 33 divided by 3 is 11. It's going to be 11. Now be very, very careful because we just divided by a negative number. We need to flip that inequality sign. It was less than, now it turned into greater than. The x is still here. Okay, we flip the inequality sign, and 7/3 does not change. So this is just -7/3. Now, when I said that you start on the left and you end on the right, I said that your best friend is the less than sign. And this is not less than, this is greater than. So we do have to switch this around to make sure that the less than sign is first. So the final answer here is going to be -7/3 less than or equal to x, which is less than or equal to 11. So make sure that you switch these. And when you switch these, your symbols are going to change to less thans. This is the answer, and this is what you want to graph. And you might be asking, how do I graph -7/3? Well, it's actually very simple. -7 is a negative number to the left of 0 or to the right of 0. It is to the left, and you don't have to find a decimal or anything. You just literally divide -7/3, and that will be all. -7/3 is 0, and you start here, you end here. So you end at 11. So hopefully this makes sense. This is solving compound inequalities. If you have any other questions or you need additional help, please visit virtualmathmasters.com/free session so that you can get your free tutoring session today. I'm going to leave the link below so you can click on it. And if you need any additional help, please let us know. We'll be here to assist you. This was your boy, Master Cruz, with Virtual Math Masters, so you never do math alone again.